All right, so this is the one that you guys haven't technically seen. So I'm going to pull up this question. If you give me a moment, let me write it down for you. So we're going to start with 2 natural log, oops, let me switch screens. 2 natural log w plus natural log x plus 4 natural log of y minus 3 natural log z equals -2. All right, then they give you 4 natural log w plus 3 natural log x plus 2 natural log y minus natural log z equals 0. And then we have natural log w plus natural log x plus natural log y plus natural log z equals -3. And here we have natural log w plus natural log x minus natural log y minus natural log z equals 3. All right. Now, what they do tell you in the question is some details, and they tell you what the values of natural log w, x, y, and z are. So typically it's a is equal to natural log w, b is equal to natural log x, c is equal to natural log y, and d is equal to natural log z. All you have to do at this point is re-express this in a matrix. So this becomes 2a plus b plus 4c minus 3d is equal to -2, and that's the first line. The second line, 4a plus 3b plus 2c minus d is equal to 0. Okay. This is just going to be a plus b plus c plus d equals -3. And the last one is a plus b minus c minus d is equal to 3. They actually give you this one as well in the chapter where we covered solving for systems of equations. All right, so this is what we have thus far. And yes, this is a 4x5 and a very challenging one at that. So let's solve for the value here. Let me take my bracelet off real quick. Give me one moment. All right. So we're going to start by creating an augmented matrix. And so I'm going to start with 2, 1, 4, -3, and the solution -2. Here we start with 4, 3, 2, -1, and 0. Here we have straight ones across. They're all positive, and a -3 for a solution. And leading to 1, 1, -1, -1, +3. And this is where we are at this moment. Okay. So the first thing I want to do is I want to swap some rows out. So I'm thinking I'm going to swap row 3 and row 1 and row 4 and row 2. So, I mean, more formal language, I would say swap row 3 with row 1 and swap row 4 with row 2. All right. And so let's begin that swap. So that means that this is going to be 1, 1, 1, 1, -3. And this will become 1, 1, negative 1, negative 1, positive 3. This will become 2, 1, 4, negative 3, negative 2. Remember, I'm swapping rows 1 and 3. This is row 3. And then obviously rows 4 and 2. So this will be 4, 3, 2, negative 1, and 0. All right. So now that we have this, we're going to start to break down our matrix. Now in this case, what I want, remember we started with the first column. I need this to be a 0. I need this to be a 0. I need this to be a 0. Okay, other zeros that we're eventually going to create, I'll start talking about in a few minutes. Okay, so to make the second row a 0, I'm thinking, what if I multiply the the first row by negative 1? And so this is negative 1, R1 plus R2. When I do that, let's do the math here. Hopefully no mistakes. It's very easy to make silly mistakes. Actually, I'm not even going to write that. Okay, so negative 1 times 1 is negative 1 plus 1 is 0. So I have now 1. This is now a 0. Remember, these are all 1, 1, 1, negative 3. So it's a good starting point, right? Okay, same thing again. So negative 1 times this 1 is negative 1 plus 1 is also a 0. Negative 1 and negative 2, negative 1 and negative 1 make a negative 2, same thing here. Negative 1 times negative 3 is 3, 3 plus 3 is now 6. Okay. The other rows also are going to change. What if I do negative 2 times row 1 plus row 3? Negative 2 times 1, look at what I'm circling. Negative 2 times 1 is negative 2 plus 2 is 0. Okay, so I've got a 0. Same thing's going to happen here. I have negative 2 times 1 is negative 2 plus 1 is negative 1. Negative 2 times positive 1 is negative 2. Negative 2 plus 4 is just 2. All right. Negative 2 times 1 is negative 2, and negative 3 is negative 5. Negative 2 times row 1 is negative 3, so that's 6. 6 minus 2 is 4, and that's what we have there. I'm going to do the same thing with row 3. I'm going to say this is negative 4 times row 1 plus row 4. Okay, so let's do the math. Negative 4 times 1 is negative 4 plus 4 is 0. We're good. Negative 4 times positive 1 is negative 4 plus 3 is negative 1. Negative 4 times positive 1 is negative 4 and 2 is negative 2. Negative 4 times positive 1 is negative 4, and negative 4 is negative 5. That's strange. Negative 4 times row 1 is positive 12. 12 and 12 minus 0 is just 12. Okay. So this is where we are at this point. So I do have these zeros wiped out. That's good. Now I'm going to consider a row swap here because I need a 1 in this place right here. So I think I'm going to go ahead and I'm going to swap row 3 and row 2. So row 3 swapping with row 2. Okay, so we are at 1, 1, 1, 1, negative 3. I'm going to swap the third row into the second row. So 0, negative 1, 2, negative 5, and in this case 4. I have 0, 0, negative 2, negative 2, 6. 1 second, Talia. And then I have 0, negative 1, negative 2, negative 5, and 12. Okay, so we'll stop here for now, and I'll continue in a few minutes. All right, so let's resume the question that we were working on. Next question. If you focus on this, you will notice, okay, so I did correct this, so I do have 1, 0, 0. That's good. Well, 1, 0, 0, 0, so it's a 4 by 4. 4 by 5. Okay, let's, if I multiply all of this by 1, I mean, I will have a 1 here, but at this time it's a little premature. Just think about that, okay? But we do want a positive 1 here, so as a rule of thumb, technically, if I multiply this row right here, row 2, by negative 1, so negative row 2, that'll become, the new matrix will become 1, 1, 1, 1, negative 3, 0, 1, negative 2, 5, negative 4. It all goes opposite, right? And then 0, 0, negative 2, 6. And then 0, negative 1, negative 2, negative 5, and 12. And that's where we are right now. All right, so I need this to be a 0, this position here in row 4. So what I'm going to do is I'm going to add rows 2 and 3. So row 2 plus row 3. Okay, so that means that I'm going to have my new matrix becomes 1, 1, 1, 1, 1, negative 3, 0, 1, 2, 5, negative 4, 0, 0, negative 2, 6. And then my new row is now going to be the addition of this for row 4. I'm sorry, I put row 3, I meant row 4. So 0 plus 0 is 0. 1 plus negative 1 is 0. That's good. Negative 2 plus negative 2 is negative 4. Okay. 5 plus minus 5 is 0. That's good. And 4 and 12 is 8. Okay, so that's what I did there. Again, focusing on the objective, which is I need 1, 0, 0, and this, and I have that. Okay. Now here, in this position, I need a 1. So what I'm going to do is I'm going to take this row, row 3, and I'm going to multiply it by negative 1/2, row 3. So what happens is my new matrix is now 1, 1, 1, 1, negative 3, 0, 1, negative 2, 5, negative 4. If I multiply 0 times negative 1/2, it's 0, same thing here. Then this becomes 1, 1, and this becomes negative 3, right? Because negative 1/2 times 6 is negative 3. Negative 1/2 times negative 2 is 1, and so on. All right, and I'll put down my 0, 0, negative 4, 0, 8. Okay, so we're good up to now. We've got a 1, 0, 0, 0, a 1, 0, 0, and now I've got a 1 here. Guess what my next point is? That has to be zeroed out. To make that 0, I'm going to multiply. I'm going to say this is going to be the result of negative 4, I'm sorry, positive 4 times row 3 plus row 4. All right, so that means that now I have 1, 1, 1, 1, negative 3. And I mean, technically, folks, notice I'm not putting the brackets until the end because I hate it when I run out of room. My writing, for some reason, changes sometimes. So, okay. Here I have 0, 1, negative 2, 5, negative 4. And, okay, so if I do 0, 0 is not going to change. So that's still 0, that's 0. That's 1, 1, negative 3. And these do not change either because I can multiply anything times it. It's still going to be 0. Now, the 1, negative, I'm here now. So negative 4, excuse me, positive 4 times 1 is 4, minus 4 is 0. Done. 4 times 4, 1 is 4, 4 and 0 is 4, so that does not change. And 4 times negative 12, 4 times negative 3 is negative 12 plus 8 is negative 4. And that's what I have so far. So far, I'm golden. Only thing I have to do now is this fourth row. I need a 1 here. So I'm going to multiply all of the fourth row by 1/4. So 1/4 times row 4. Apparently that's a 4. So now I have, this becomes 0, 0, 0, because 1/4 times 0 is just going to be that. This 4 becomes a 1. And this negative 4 becomes negative 1. Okay, so far I'm happy with these steps, because if you notice, I have that pattern going on where I have 1, 0, 0, 0. I have a 1, 0, 0. Here I have a 1, 0, and here I have a 1. And I want that because that's at least getting me to the Gaussian elimination. So I can use back substitution to solve for this at this point. Just remember, this means that this is W, X, Y, and Z. So that I know that my Z is equal to negative 1. Based on this equation, Wx, because remember this is Wx, Y, Z as well. So you have Y plus a Z, or in this case a 1, is equal to negative 3. So I can solve for this, and I know that Y is equal to negative 4. Okay, so I have Z, I have Y. Can I solve for the next one, which is X? Or actually this is WXYZ? I'm pretty sure it's WXYZ. How did they write this? Let me see. Yeah, WXYZ. All right. So X, in this case, since there is no W, it's simply X minus 2Y plus 5Z is equal to negative 4. And if I substitute what I do have, I can solve. Because I know that in this case, Y is 4, and I know that Z is negative 1. So solving for this, I have X is equal to negative 2, or yeah, negative 2 times negative 4 plus 5 times negative 1 is equal to negative 4. Okay, so I have 8 minus 5 is equal to negative 4. Sorry, that's X minus 8 minus 5. Let me reverse that. This becomes X minus 2. So I have X minus 2Y. Y is negative 4, so it becomes plus 8. So I really have X plus 3 is equal to negative 4. And so therefore X is equal to negative 7. All right, and so we continue working backwards. Minus 2Y plus 5Z equals negative 4. All right, and I know that Y is negative 4, so that becomes plus 8. Just checking the math real quick. And then 5 times negative 1 is negative 5. Yeah, okay. I'm comfortable with this so far. Okay, so we have X, Y, and Z so far, at least. Now we solve for W. Now in this top equation, we have W plus X plus Y plus Z equals negative 3, which gives you W minus 7 minus 4 minus 1 is equal to negative 3. So that means that this is W minus 12 equals negative 3. And if I add the 12 to both sides, my W equals 9. Now, we have those values. Here's what you need to remember. If we go back to the original equation, remember that A is natural log W, B is natural log X, C is natural log Y, D is natural log Z. We just solved for W, X, Y, Z. All right. I'm trying to shrink it so I can see everything. So that means I have that a value, for example, is equal to the natural log of w. A is equal to natural log of 9, as an example. According to the equation, you have 2 times natural log of 9. Now, natural log of x is going to be interesting because the natural log of x, that refers to the b. So b is natural log of x. That means that b is equal to the natural log of -7, which we already know an answer for that, right? For c, we have c is equal to natural log of y. And according to our y, it's -4. So c is equal to natural log of -4. And for d, we have d is equal to natural log of z. So that means that d is equal to the natural log of -1. Okay, supposedly, according to this line, this value, and notice that I stopped writing here. I haven't even bothered to write here. What do we know about natural logs and negative numbers? Okay, so think about that for a second. And if I pull up a calculator, I guess I can demonstrate it on the screen. So let me do that. Let's look at it on the screen. Let's just pick natural log of -1. Let's see what happens. Here's natural log. Let's do integer -1. I'll even give it the parentheses. So go see what it says. Non-real answer. So if you notice, I didn't bother with the solution set for this. So according to this, 2 times natural log 9 should be equal to -2. And that's if I add all of these values to it. So